This chapter, some application of trigonometry. Let's do a module where we are learning sums based on angle of elevation and depression. So it's based on both, right? Let's see the sum first. The sum says that from the top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 degree and the angle of depression of its foot is 45 degree. Determine the height of the tower. That means from this we understand that there is a building and a tower. That is the first thing which we get. So we have a building and a tower. Let's read the first statement. It says from the top of a 7-meter high building. That means first we have to consider the building and the height of the building is given as 7 meter. This is the first information which we have. The sum says from the top of the first building. That means from the top of the first building, the angle of elevation. That means there is a person at the top of the building and from there he is making an angle of elevation. That means he is seeing above the horizontal line. What is he observing? The top of a cable tower. Okay. So first we have an observer at the top of the building. The moment you have an observer, first we need to have a horizontal line. Now he is not on the ground, he is on the top. So from there you draw an horizontal line parallel to the ground. Now he is observing the top of the cable tower. So when he is observing that, there is a line of sight. And this line of sight is making an angle of elevation which is 60 degree. Wasn't that easy? Simple, right? We understood this. Now let's go on to the next part. And the angle of depression, that means now from the same position, he is looking something at a lower level, below the horizontal line. What is he observing? Angle of depression of its foot. That means he is observing the foot of the cable tower. And when he is observing that, that line of sight makes an angle with the horizontal line. And that angle is given as 45 degree. So this is what we have made. And they say determine the height of the tower. That means you are talking about the height of that cable tower. That is what we need to find. That means that particular segment is something which we are supposed to find. So this is the figure which you draw and we'll just name the figure for our understanding. So this is the final figure which you actually happen to draw. But you're not going to draw a building and a tower like this. You're just going to draw a figure like this. Now let's describe the figure. Let's describe the important parts of the figure. So in this figure, we know that this CD is something. What is that? It's the height of the cable tower and we take that length to be h because that is what we are supposed to find. So let us take it to be h meter. Then we have AB. What does AB represent? AB represents the height of the building and which is given as 7 meter. There are two angles given to us. Angle CAE we have a 60 degree, angle DAE we have 45 degree. Now by using this information we need to find the length of CD. That means we need to get the value of h. Now how are we going to get that? For that, observe that quadrilateral ABDE. Observe that quadrilateral. In that quadrilateral, if you observe carefully, that quadrilateral AB and it's a rectangle. Why it's a rectangle? Because each angle is 90. In that AB is equal to D. Can we say that? Yes, we can say because opposite sides of a rectangle are equal in length. That means length of AB is 7. So length of ED will also be 7 meter. Now understand one thing, if you observe that 7 meter which we got DE, now DE happens to be a part of that CD. So observe CD very carefully. Now you observe CD, that segment is made up of two different parts. That is what you're supposed to find, right? Observe it is made up of CE and ED, right? And length of ED we know is 7. So with the help of this, can we find the length of CE? Yes, we can. So we can write CE plus ED we know is equal to CD. So when we substitute the value of CE, we don't know CE, keep it as it is. We know the value of ED. What is that? It is 7. And we have taken CD to be h. So from this we can say that the value of CE is nothing but it is h minus 7 meter. So this is what we obtained now. So we have the length of CE right now. Easy? Simple. So, but for this, to calculate this value of CD, we need to get the value of h, right? That is h we need to get. So how are we going to get it? Now observe there are two acute angles. One acute angle 60 degrees is there in right angle triangle AEC. The other acute angle is in right angle triangle AED. So let's use this information. Let's use this right angle triangle. So let's consider right angle triangle AED. Now observe in this right angle triangle, which is the angle, acute angle we know, it is angle EAD. Observe that angle EAD. For that acute angle EAD, we know the opposite side, that is ED. And we will find the adjacent side, that is AE, because that AE happens to be the common side for both the right angle triangle. And remember, I have always said, remember when you have two right angle triangle, focus on getting that common side. So that common side we need to get, that is the adjacent side. So here we are talking about a ratio which involves opposite side and adjacent side. And as we know, that ratio is going to be tan. So we're going to use tan of 45 degrees. So we know that tan of 45 is opposite upon adjacent. That means it is ED upon AE. Now substitute the value. The value of tan 45 we know is 1. So substitute that value. Is equal to ED. The value of ED is how much? 7. Beautiful. And the value of AE we don't know. Keep it as it is. So now we get the value of AE by cross multiplication to B. We get AE 7 meter. So you got the value of AE, right? Now that common side we obtain. Now this is something which will help us to obtain the value of H in the next right angle triangle. So the next right angle triangle, what we have is AEC. In that right angle triangle, focus on the acute angle. What's the acute angle there? That is angle A. Observe that angle A. Now for that angle A, we have the adjacent side and the opposite side involving H. So opposite side is CE and the adjacent side which we know is AE. So again we are talking about opposite side and adjacent side. So this reminds us of which ratio? It's nothing but tan. So now use tan for 60 degrees. So we write tan of 60 is equal to opposite side, that is CE, upon the adjacent side, that is AE. Now you know tan of 60? Yes, from the table we know that tan of 60 is nothing but it is root 3. Substitute that value. Is equal to CE we know is H minus 7 and the value of AE is nothing but it is 7. So now cross multiply. So we get 7 into root 3 is equal to H minus 7. Beautiful, right? Now you want the value of H. So keep H on one side. Take the numbers on the other side. So we get 7 root 3 plus 7 is equal to H. So hence we get H is equal to, here we can take 7 common. So into bracket we'll get root 3 plus 1. But you know what? We know the value of root 3. How much is that? It is 1.73. So substitute that value there. 7 into bracket 1.73 plus 1. And we know 1.73 plus 1 is how much? 2.73. So we have H is equal to 7 into 2.73. And now you multiply that. We get it as 19.11. That means we got the height of the cable tower is 19.11 meter. Wasn't that easy? A very important sum.